Let us now see some properties of the vectors. Suppose that we have three vectors u, v, and w, and two scalar quantities c and d. The first property says that it doesn't matter which way we add two vectors, so the vector v plus u will be equal to the vector u plus v, and therefore the commutative property holds in the addition between two vectors. Now, the second property, if we add two vectors u and w, and then add to that the vector v, this will be equal to adding the vectors v and u to the vector w. So then, in this case, the associative property holds for vectors. Now, if we have a vector v and we add that to that the zero vector, this will give us the vector itself. So essentially, we have the same thing as we would have with a number. If we add to a number the number 0, then we get the same number. And then if we add to a vector its opposite vector, that gives us the 0 vector. And again, we have an identical property for numbers. If we add to a number its opposite, then that will give us the 0 number. And then if we have a scalar quantity c and we multiply that to the sum between the vectors v and u, then that would be equal to c times the vector v plus c times the vector u. So in this case, we have a distributive property for the vectors. And also, if we have a sum between the two scalar quantities c and d times the vector v, then we can distribute the vector v inside the parentheses, so that will be equal to c times the vector v plus d times the vector v. Now, one other property is if we have the product between the two scalar quantities c and d, and then we take the scalar multiplication of c and d with the vector v, then that would be equal to c times the scalar multiplication of d times the vector v, and of course this would be equal to d times the scalar multiplication of c times the vector v. And one final property is if we multiply the vector v by the number 1, this will give us the vector v itself.